All right. I am going to... what's that? Okay. I'm going to work number 38. It says a warehouse worker pulls handles of a 96.0 kilogram cart with a net force of 128 newtons at an angle of 55.0 degrees above the horizontal. Attached to the cart is a smaller cart having a mass of 72.0 kilograms. What is the magnitude of the horizontal acceleration of the less massive cart? Now, guys, I think a lot of times you're just panicking at the problem and not even trying to break it down. I just want to make sure that you always start, even to me this problem looks overwhelming, until you realize that all you need to do is write down the given information and draw a picture. So, a warehouse worker pulls on the handles of this cart. So, let's draw the cart. I'm just going to draw it in space right now because I really don't understand even what's going on with it. But I know that the mass is going to be equal to 96 kilograms. That is not a force weight, guys. I'm just labeling that because I can use it to do the force weight. Okay. With a net force. Pulls on the handles of this cart with a net force. Force pull of 128 newtons at an angle of 55.0 degrees. All right. So this is cart 1 and this is cart 2. They want to know what the acceleration of cart 2 is. Acceleration of cart 2. So we know mass of cart 1 is this, mass of cart 2 is 72.0 kilograms. Mass 1, reset to give myself a little more room. Kilograms. Alright, I hope you all were able to at least draw a picture. Now, some of you might have thought it might have been hanging, but they would use the word hanging for the second one. It says attached, and it says that it's pulling the cart. So I hope this is the logical image that came up in your minds to what is happening here. So, are we ignoring friction or is there friction? Oh, it says net force. Okay, so since this is the net force, it'll be the net force in the x direction. So what we will do is all we need to find are the components. Everything is shoved by pen off an accident. So we got to find the force pull in the x and the force pull in the y. If we really wanted to, I don't think it's going to be relevant for this problem because we're really just focusing on what's happening in the x direction, and I believe we're going to have enough information to solve it without worrying about the y. So force pull in the x is going to be your adjacent angle. So remember, SOHCAHTOA, adjacent is cosine, so cosine of 55 degrees is equal to your adjacent, which is your force pull in the x, over your 128 newtons, which is your hypotenuse. So cosine of 55 degrees times 128. My force pull in the x is equal to 73.4 newtons, 3 sig figs. All right. So they told me this is my net force. Remember, my force net in my x is going to be equal to, I don't know, I started writing net and then stopped, but we're just going to say force in the x here. It's the summation of the force. That's what that symbol means. Sigma. Mass times acceleration. If this force is being pulled here, it is also pulling on that guy. So let's figure out what that pull is. So I'm going to give you a second. I feel like you might have really struggled on setting up this problem. So if you want to pause the video or look here so you can see if you can sum them up. What are the forces in the x direction? All right. The forces in the x literally are just this force that we're looking for, or that they gave us, but we solved. So this is literally the only force there. So my summation of my forces in the x, again, the reason being is because they said net force. So all we had to do is resolve it to find it. Now the mass, that's the tricky part here. You're going to have to realize that because they're attached, they're going to have the same acceleration. But the mass that we are moving is both carts. So we have to take this 72 kilograms and the 96 kilograms and add those two together. So 72 plus 96 gives me 168 kilograms times the acceleration in the x direction. So all I need to do is divide both sides by 168. I want to remind you that because I'm dividing by 168 kilograms, I'm going to break this unit down for you over here. So let's look at this. Remember, 1 newton is equal to 1 kilogram times meters per second squared. And if we're dividing by kilograms, kilograms cross off, and I'm left with meters per second squared. So on my calculator, I'm going to type in 73.4 divided by 168. Oh, I hit the negative sign instead. Shoot. 73.4 divided by 168. Now I get an acceleration in the x is equal to 0. And I'm going to 3 sig figs, so 437. Remember, the SI base for acceleration is meters per second squared. And through my dimensional analysis over here, I showed you that that is exactly what you ended up with. That should be the solution, the answer for number 38.